For tonight's homework, we're going to continue exploring linear relationships. So make sure you've completed page 12 so you're ready to correct it. The graph below represents the walkathon pledge plans for 3 sponsors. Describe each sponsor's pledge plan. So what do you notice is happening with sponsor A? Well, I notice that sponsor A is starting at 0, 0. And I notice it's a straight line, so I'm expecting that it's a proportional relationship, that it's going to fit that formula of y equals kx. And so I need to think about now, what is the constant rate? So as I go over 1, how far am I going up? Well, I can see for every 1 kilometer, I'm going up $3. So I'm going to say sponsor A, they're getting $3 per kilometer. For sponsor B, a pink line here, I can see that sponsor B is getting the same amount no matter what they walk. So they're kind of getting like a fixed donation. So they're just getting $5. Doesn't matter how far they walk. And for sponsor C, the purple line, I can see that they're getting some type of donation to start. So I see a y-intercept value that's not necessarily 0, 0. So I'm expecting that's going to be a linear relationship, since I see it's a straight line that's going to follow this pattern. And so looking at it, I see that they get a $2 donation, and then they're also getting some amount per mile. And this is a little trickier to see. It's sometimes really good to look for points that intersect exactly. So for example, I can see some of these points here where it's really clear what they go with. So in this case, I can see if they go 2 kilometers, they're going to increase the amount of money that they have by $3. And so I can even just say here, they're going to get $3 per 2 kilometers. Now that's not a unit rate, but we're going to deal with that actually in the next problem. So now how many dollars per kilometer does each sponsor pledge? Well, for sponsor A, we can see that they're pledging a specific amount. Every kilometer they're increasing by $3. So $3 per kilometer. That's that constant rate of change. That is our constant of proportionality, since it's a proportional relationship. For sponsor B, we can see that that line is a horizontal line. That means it's not changing. So you can either say it has $0 per kilometer, or that there's no change, no amount that's being pledged per kilometer. And then for sponsor C, this is the slightly trickier one. So we were just saying it's kind of like it goes up a certain amount, right? Every 2 kilometers I walk, I go up $3. So $3 for 2 kilometers is equivalent to $1.50 for 1 kilometer. And I can kind of see how that matches up here. If I go over 1 and then up, I get up about $1.50. So what's the point, or what does the point where the line crosses the y-axis mean for each sponsor? Well, in this case for sponsor A, where it crosses the y-axis at 0, 0, tells me they start with 0. And that's also, again, part of what makes it a proportional relationship. For sponsor B, the red line, I see that sponsor B is going to start at $5. And for sponsor C, I can see that sponsor C is starting at $2. Do you remember what it's called? When we talk about that starting value, that's talking about the y-intercept. So again, as we start practicing more with the formula for a linear equation, you're going to see a lot of y equals mx plus b. Keep in mind that our b value there is going to be our y-intercept, where we start the graph. And our m value is going to be our rate, which we're also going to call our slope. So keep an eye out for those things as we're looking at these situations. And now we're going to write the coordinates of 2 points on each line. So there's lots of possible answers here. For example, I noticed for sponsor A that it goes through the origin 0, 0. So that might be one of my points. I could also pull out this point right here, which is going with 3, 9. Lots of different combinations there. For sponsor B, again, I could do 0, 5, which is where it crosses the y-axis. I could also do 4, 5. And for sponsor C, I could use the y-intercept as one of the points, so 0, 2. And pulling out another point here, I can see I've got a point right here at 2, 5. So again, as long as the points that you pick are on the line, you're on track. So does each relationship represent a proportional relationship? Well, I'm hoping that you're starting to recognize that if it's starting at 0, 0, it is proportional, and it must also be a straight line with a constant rate. So looking at sponsor A, starts at 0, 0, and it has a constant rate of $3 per kilometer. So yes, it's a proportional relationship. With B, I can see here, it does not start at 0, 0. It stays at 5 all the way across. It does not fit the qualities of a proportional relationship. So unfortunately, no. And for C, I can see that it is a straight line, but again, it's not starting at 0, 0. So unfortunately, that's going to be a no. For your last problem, the students in Ms. Chang's class decide to order water bottles that advertise the walkathon. Hyuna obtains 2 different quotes for the cost of the bottles. For each company, write an equation to calculate the cost for any number of bottles. Well, I can kind of see 2 variables here. Cost, I'm going to call that C, and number of bottles, I'm going to call that B. So make sure you decide how you're going to label your variables. So I have to think also which one is my independent variable and which one is my dependent variable. Does the cost depend on the number of bottles, or does the bottles depend on the cost? Well, in this case, I want to calculate the cost. That's what I'm going to be finding. And so I'm going to be putting in a number for the number of bottles. So that's going to tell me that, I'm going to jumping ahead a little bit here, but that's going to tell me that my number of bottles is my dependent variable. And my cost is my independent variable. So when I set up my equation to calculate the cost, each one is going to start with C equals, because I'm solving for the cost. And I'm going to have bottles in each equation as well. So now looking at fill it up, it's $4 per bottle. So I'm seeing there a constant rate, $4 per bottle. So I'm going to plug that right in here. C equals 4 times B. Again, this fits y equals kx. So you should be able to think that that is what type of relationship? Proportional. Bottles by Bob, we have a $25 setup fee and then $3 per bottle. So in our equation, we're going to have C equals 3 times B for $3 per bottle plus 25. Again, this fits with the format y equals mx plus b. So I have a slope or an m value. You're going to learn about that as slope very soon. I also have a b value, a starting value for the $25 setup fee. So now that we have 2 equations, I'm being asked to graph them. And so again, I set up bottles here on the bottom and cost here on the side. And you can kind of choose how you want to set up this graph. I'm just going to go by ones for bottles here on the bottom. And for cost, one of the things I notice is that there's a $25 setup fee. So I know that one of my first values is going to be 25. So maybe I will go by 5s. Just choosing something to start with here. And again, if you set this up a little bit differently, that's fine, as long as you can see the relationship that's there. So when I use fill it up, I'm going to graph that line here in red. My equation is 4 times B. So every time I add a bottle, my cost goes up by $4. So $4 for 1 bottle, right? 0 is going to be $0. 2 bottles is going to be 8. 3 bottles is going to be 12. 4 bottles is going to be 16. So I can kind of see this line's going up like this. Ideally, it's a straight line. And you can hopefully use a ruler to make yours even better than mine. And then we need another one for bottles by Bob. We're going to do that one in green here. So this time we have a setup fee. And so make sure you're starting your equation at 25. And now we're adding $3 per bottle. So if I add $3 to 25, I'm at 28, plus 3, I'm at 31, plus 3, I'm at 34, plus 3, I'm at 37, plus 3, I'm at 40. And so again, you can see this guy here going up also. So next question that I have here is, which variable is the independent variable? I'm hoping you're thinking about how the independent variable is the x-axis value. And so when we're looking at what's on the x-axis here, we see the bottles. So bottles is the independent variable, the number of bottles, and the dependent variable depends on that. That would be the cost. So from which company do you think the class should buy water bottles? Talk about which factors influenced your decision. That's a question we're going to explore more in class tomorrow. So come with your answer prepared to discuss which company you should buy bottles from. There's all sorts of variables to consider. All right, we'll see you in class tomorrow.